Okay, so 12b, again, it does not factor by grouping, so I'm going to have to use the P over Q method in synthetic division. The P factors are plus and minus 1, plus and minus 2. The Q factors are plus and minus 1, 2, 3, and 6. So now I'm going to do the P over Q over here. So I'm going to take the 1 and put it over each one of these. Then I'm going to take the 2 and put it again over each one of these. So what I get, and notice I just put a plus minus in the front of the braces. And so I have plus or minus 1 over 1 is 1. Then 1 over 2 is 1 half. 1 over 3 is 1/3. 1 over 6 is 1/6. Then 2 over 1. So 2 over 1 is 2. 2 over 2 is 1, and I already have it. Then 2 over 3. And 2 over 6 is 1/3, and I already have it. So here's the list. So it's 1, 2, 3, 4, 5, 6, 12 possible numbers, right? Because there's a plus minus in front of each one. So I'll start with 1. Set it up with synthetic division. So bring down the 6. Add. And doesn't work because the remainder is not 0. I'll move on to 2. Bring down the 6. Add. Add. And this one worked, okay? So now I'm going to try to factor, see if this factors, because remember this is a quadratic, 6x squared plus 5x plus 1. So factors of 6 that add up to 5 are 3 and 2. So I'm going to make the little box. 6x squared, 3x, 2x, and 1. Greatest common factor in the first row is 3x. Then that gives me 2x right here and a 1 right here. And then 2x times 1 is 2x. Okay, so that works. So f of x equals, so from this 2 right here, I write this factor. And from the quadratic, I get 3x plus 1 and 2x plus 1. So that's the factored form of a polynomial. The zeros are 2, negative 1/3, and negative 1/2. Because remember, we set up each factor equal to 0 and solve for x. So like this. And then we solve each one. And that's how I get the zeros right here. Alright, so we have to find the zeros and then the multiplicity of each zero. So the first one is 0 because x is by itself. Its multiplicity is 2, which is an even multiplicity. The next one is positive 1. Its multiplicity is 2, so that's an even multiplicity. And then the third one is negative 2, which with a multiplicity of 3, and that's an odd multiplicity. Alright, for letter B, I have negative 4x squared. Again, x doesn't have anything added or subtracted to it, so the 0 is 0, with a 2 for multiplicity, which is even. Then negative 1 with multiplicity 3, which is odd. And then negative 2 with multiplicity 4, which is even. So for 14, they want you to write a polynomial with of least degree and leading coefficient 1 with these zeros. Now, they only gave you, for A, they only gave you 1 and 2i, but you know that all imaginaries have to have a conjugate pair as a 0, so its conjugate pair is negative 2i. And I've already set it up, so here's the 1, here's the positive 2i, and here's the negative 2i. Notice that every factor is set up x minus, okay, x minus. So now we're going to simplify, and I get x minus 1, x minus 2i, and x plus 2i. I'm going to multiply these together, and I'll just bring down the x minus 1. So this is x squared, now plus 2xi, and then minus 2xi, and then minus 4i squared. Well, these two cancel out. You get 0. And remember, I squared is negative 1. So we have x minus 1 times x squared plus 4. Because this is a negative 1, and then you have a negative right there, so that makes it positive. So I can use, since it's two binomials, I'm just going to multiply them together. So let me give this polynomial a name. So f of x is x cubed minus x squared plus 4x minus 4. And I just did distributive property. And rearrange the terms. Okay, so for letter B, we have to add 1 plus 2i, the conjugate pair. And so we're going to say f of x equals x minus 2, x minus 1 minus 2i, and then x minus 1 plus 2i. Notice that all the zeros, or all the factors, have the same pattern, x minus, okay, whatever the 0 is. So the next step is I'm going to simplify, like this, distribute the negative, so that I don't have any like parentheses inside parentheses. Okay, so I'm going to multiply these together because they have eyes and the imaginary term. So I'm going to multiply by using a 3x3 grid. I know there's that line in the way, I can't get rid of it, so just ignore it. So x minus 1 and 2i, x minus 1 and minus 2i. We're going to multiply x squared minus x minus 2xi minus x 1 and then 2i and then 2xi minus 2i and minus 4i squared. Okay, this one and this one are 0, cancel. This one and this one cancel. And negative 4i squared is actually plus 4. So I could get rid of that one and replace it with plus 4. So now I have x minus 2 times, excuse me, x squared, combine like terms, 2x, and then I have this 1 and this 4, it's actually 5. So I'm going to multiply these two together, and I'm running out of room, so I'm just move it over a little bit. So because of room, I'm just going to put it up here, and I'm going to do it vertically like this. So x minus 2 goes here, x squared minus 2x and 5 right here. I'm going to multiply, so this is x cubed, negative 2x squared, negative 2x squared, 4x, 5x, and negative 10. So these two combine, and these two combine. Okay, so your final answer is f of x equals x cubed minus 4x squared plus 9x minus 10. Right there. Okay, so 14C, they gave you 2 zeros, and you had to add the third one because just like with imaginary numbers, square root numbers or radicals have to have their conjugate pair also. So right here in green right here, excuse me, you have the conjugate of this one. So again, notice the pattern, the structure. all the factors have x minus, x minus, x minus their respective zeros. And so in the next step, I'm going to simplify. So let me change this to x plus 1. Then I'm going to distribute the negative, minus 2 minus radical 5, and then x minus 2 plus radical 5. So I'm going to multiply these two together first. Again, it's a 3 by 3, so I'll just put it right here. Give myself enough room. Oops, maybe not. We'll see. X minus 2 minus radical 5 minus 2 and positive radical 5. We're multiplying. So this is x squared, negative 2x, x radical 5, negative 2x, 4, negative 2 radical 5, and then negative x radical 5, 2 radical 5, and negative radical 25. So this one and this one is 0, this one and this one is 0, and this one is negative 5, right? Square root of 25 is 5. So now I have x plus 1, and then x squared minus 4x, and 4 plus negative 5 is negative 1. So now I'm going to multiply these together. You can just do straight distributive property. I'm going to put them in a 2 by 3. x1, x squared minus 4x minus 1. So that's x cubed because we're multiplying. Negative 4x squared, negative x, x squared, and negative 1. So like terms are this one and this one, and this one and this one. So you would write f of x equals x cubed minus 3x squared minus 5x minus 1. Alright, so we're going to simplify the radicals. And so the first one is square root, right? So that means we need pairs of factors in order to take them outside of the box, outside of the radical. So 20 is 4, let me first change the color. 20 is 4 times 5. So the 4 comes out as a 2, and the 5 stays inside. For x cubed, I can write it as x squared times x. So this one comes out as an x, and the one that's by itself, the x stays inside. And then the y, I can write it as y to the 6 halves, okay? Or I can write it y squared, y squared, y squared, right? That's y to the 6. So either one. So this goes like this. So the 4 comes out as a 2, this one. The x squared comes out as an x, so it's gone. And these 3 y's each come out as a y, so there's 3 of them, so it's y cubed. Inside the radical, I still have the 5 and the x. And that's the answer. Okay, and this is a 2, not a z. For b, it's 4th root, so we need 4 of the same. Okay, and then after I do the 4th root, I'm going to square it. I know on this copy it doesn't come out very clear, but there's a square right here. And maybe I should write it outside to make it more obvious. Right there. There's a square right there. Excuse me. So 16 is 2 to the 4th. A to the 8th, I could write it as a to the 4th times a to the 4th. B I could write as b to the 4th times b to the 4th times b to the 4th. Okay? And remember, it's still inside the 4th root. So I need 4 groups of 4. So the 2 comes out as a 2. Each of these a's comes out as an a, so that's a squared. And each of these b's comes out as a b, because each of them is to the 4th power, so that's b to the 3rd. And nothing is left inside, okay? But we still have to square it. so now it's 4. When it's power to power, you